Okay, all right. So guys, this is the lesson number 2 for your Form 4 chemistry. Yeah. So we will take a quick 3 to 5 minutes to do a recap on what we have learned last week. So we will do a very quick summary what we have learned last week. Okay. So last week we started with chapter 2 because I told you in chemistry chapter 1 is not important at all. For Form 4 chapter 1 is not important at all. It's just a very basic introduction, just an introduction to chemistry. So basically, we only need to focus on chapter 2 and onwards. Yeah. So we started with, we learned what is matter. Anything that has mass, anything occupied space, they are classified as matter. Yeah. We are doing a quick summary here. So we know all the matter, all the chemical substances, they are made from tiny and discrete particle. Okay, what do we mean by discrete? Discrete means the particle can be separated. Those particles, they can be separated. So that is what we call discrete. So there are total 3 types of particle in chemistry, which is atoms, molecule, and ion. So make sure you know how to differentiate atoms, molecule, or ion. So whenever I give you a substance, you must be able to tell me whether the substance is an atom, molecule, or ion. Yeah. So then we also know that ion means something that got charged. Anything got charged is called ion. So we have cation and anion. So cation, as you can see, the T here looks like positive. So it's positive ion. Anion, the N's that stand for negative. So it's negative ion. So this is something that we learned in the last lesson. So last lesson, we also cover a concept called element, compound, and mixture. So I hope everyone still remember what it is. So if you kind of like forgotten already, please refer back to last week lesson. You can look back, you can revise back to the last week lesson, okay, based on the video recording. Yeah. So then we also cover state of matter. So state of matter means solid, liquid, or gas. So the matter can exist in solid form, liquid form, or gas form. So I mentioned how to draw the solid, liquid, and gas. And you must know the way how you draw in your SPM is different from what you learn in your Form 2 or Form 3. Because in Form 1, Form 2, Form 3, they didn't, they are not so strict when it comes to the drawing. But when it comes to SPM, there are a lot of small details that you need to know when you come to drawing. Okay, all these things I mentioned in the last lesson. So then we also need to know how to compare the solid, liquid, and gas. We must be able to compare their arrangement. We must able to compare their kinetic energy. We must able to compare the force of attraction. What are the force that we have? Okay, and then we must know what kind of movement. So remember, in chemistry, there are 3 types of movement. We have vibration, rotation, and free movement. So make sure you know solid, what kind of movement they have. Yeah, liquid, what kind of movement they have. Gas, what kind of movement they have. So all these things we learned in last lesson. So last lesson, we also learned about change in the state of matter. You can change from solid to liquid to gas and so on. Yeah. So this is a very quick summary. Okay. So what is the name of the process when you change from one state to the other? And always remember, when you change from one state to the other, the mass doesn't change. Example, if you have 1 kilogram of water, if you boil it, you will get 1 kilogram of steam. The mass is not going to increase or decrease. The mass is always the change, so always the same when you change the state. And make sure you know all the processes in red color means the process need to be heated. All the processes in blue color means the process need to cool down. Yeah. So nothing new. All these things you learn back in PT3. We just do a quick summary. So that's what I mentioned last lesson. Last lesson is quite a honeymoon, a very simple lesson, because many things that you learn in last lesson actually is something that you had learned back in your PT3. Yeah. So then we also talking about the differences between boiling and evaporation. So boiling and evaporation, these 2 processes change liquid to gas. but they are different, okay? So boiling only happen at boiling point. Evaporation can happen at any temperature. Any temperature also can have evaporation. Boiling happen in the whole liquid. So evaporation only happen on the surface, yeah? So all these things we learn. So, and then I also told you there are 4 chemical substances that can undergo sublimation. There are 4 chemical substances that can undergo sublimation. Sublimation means they can change from solid directly to gas without without becoming liquid. They can change from solid to gas directly. Okay. So that's it. And make sure you know if you change from gas back to solid, this process called deposition. Because for some of the school, they only teach you sublimation in PT3 and they didn't cover deposition, okay, in your school. So it's good to know that. All right. So then the last thing. So last thing before the class ended in the previous lesson, we cover something called 3 lines method. So 3 lines method is used to predict whether you have a solid, liquid, or gas when the question gives you melting point and boiling point. Question gives you melting point, boiling point, then they ask you to predict whether you have solid, liquid, or gas at a specific temperature that you wanted. Yeah. So we covered 2 examples. Okay. So this is everything that we learned in the last lesson. So I hope everyone still remember. So if you missed out last week's lesson and you didn't watch the recording yet, probably you'll find it a little bit blur. You will feel like you get lost a little bit, which is okay. No worry. Later on, when you're free, watch the video. And if you still have any question or any doubts, anything you don't understand after watching the video, you can ask me anytime. Yeah. All right. So before I move on and continue to learn something new today, it's everyone okay so far? Okay, so it's always good for us to do a quick summary, like at least you still remember what you learned last week, because some people are very forgetful one. Whatever thing they learned last week, they forgotten already. So at least we do a quick summary first. Okay, so now before we learn something new today, I would like to do another few more questions with you. Let's spend about 5 to 10 minutes to do some additional questions. Then I'll teach you something new today. Yeah. So let's start. Okay, so like what I say, if we really want to do question, make sure we do some good quality question. So good quality question is the question that we get from trial exam paper or SPM, a real past year paper. Because I mentioned last week, if you do the question from some reference book, the question might be too easy or too hard. Yeah. So I don't want that. I want you to do the question which have good quality, those exact format of question in the real exam. Okay, let's start with this. So the first question is this. This is the Kelantan question in year 2022. This is year 2022 Kelantan trial exam paper. Soalan percubaan. So you are given 4 substances, PQRS. They give you the melting point and boiling point respectively. They give you the melting point, boiling point for PQRS. They ask you, among the 4 substances, who is gas at room temperature? Okay, guys, allow me to ask you all. How much is room temperature again? Room temperature is how much? I mentioned this last week. Anyone? Okay, very good. Okay, so Li Elena, Joseph, Shinin, okay, Yi Zheng, Jen Yen. Very good. 25. Room temperature is 25 degrees Celsius. Fantastic. So how to do it? You can use a 3-line method. So do a 3-line method. Let's say for substance P. Substance P 3-line method. This is solid, this is liquid, this is gas. So melting point is 80. Boiling point is 120. So room temperature is 25. So where is 25? 25 is around here, right? 25 is less than 80. So around here. So it should be a solid. So P is wrong already. So P is a solid. I want a gas. So since the P is wrong, answer 1 is out. So answer 1 is out, A is out, B is out because they have answer 1. So now you shortlist the answer to C and donkey. So when you do objective question, it's always a good idea to eliminate, to throw away those wrong answers. Yeah. So now Next one. So substance Q, let's do the three-line method. So substance Q, what is the melting point and boiling point? 50 and 95 respectively. So what we want, room temperature 25. Where is 25? 25 is less than 50, so it's somewhere here. So also a solid. So I don't want a solid, I want a gas. So Q also wrong. So Q is number 2, which is wrong. Number 2, it's wrong. So this answer C got number 2, so it's wrong. So the answer has to be donkey. Okay, 3 and 4. Yeah, so that's it, right? So that's how it works. Okay, so anyone have no idea what is happening here? Anyone? So if you missed out last week's lesson, probably you might find it a little bit blur. That's why I say you go and watch back the last week replay first. Yeah, right. This is a method I mentioned in the last lesson. Okay, for those who attending last week lesson, are you guys okay with this 3 lines method? Are you guys okay with 3 lines method for those who attended last week lesson? Okay, it's quite easy, isn't it? Yeah. All right. Very good. So now let's do one question. Okay, so far all the questions that we have done, they are all objective question. What if I show you some subjective question? So if they want to ask you this kind of question in subjective, so in the writing paper, in the paper that you need to write, how can they ask the question? So let me show you one before we go on and learn something new. Okay, this is a question from para. This is a para state paper, year 2022. So you are given 4 chemical substances. They give you the name and also they give you their chemical formula. Yeah. So first question, they ask you, can you tell me what is the type of particles of tetrachloromethane? So allow me to ask you all a simple question. How many types of particle in chemistry? Give me a number. How many types of particle in chemistry? Okay, very good. 3, yeah? We have 3 particles. Can we do a 1-minute revision? So the particles can be atom, can be molecule, or can be ion. So how are we going to differentiate atoms, molecule, ion? How to know the substance is atom, molecule, ion? So I told you last week, atom is something who are alone. Anyone who have no friend, they are atom. What is molecule? Molecule is non-metal gang. What do you mean by non-metal gang? When you have non-metal and non-metal combines together. Non-metal and non-metal, they combines together. That is molecule. What is ion? Ion is somebody who got charged or combination of metal and non-metal. Okay, everything we learned last week, I just want to teach you how to apply whatever knowledge, whatever concepts that you have learned. Okay, so let's hear. So they asked us about this fella, tetrachloromethane. While the name looks very long and sounds horrible. Doesn't matter. So let's look at it. Tetrachloromethane is here. Formula given CCl4. So CCl4, what we can see, the C here is carbon. So carbon is a non-metal. This Cl here is chlorine. Chlorine also a non-metal. So when non-metal and non-metal join together, can you tell me what is it? What is it? When non-metal and non-metal join together, what is it? Okay, very good. Okay. All right, Cecilia, Shinin, Joseph, Aliyah, very good. Molecule. So they are molecule. So just write M-O-L-E-C-U-L-E, molecule. Okay, you can write molecule or molecules. With or without S is okay. All right. So they didn't check so much on your grammatical mistake. They don't care you're writing a singular or plural. They don't care. So you write molecule or molecules. Both answers are acceptable. Because the main focus is not the English. The main focus is the chemistry concept. Yeah, that's all. Okay, all done. Okay, let's move on to this. Okay, now you have these 4 substances. Now you need to do a classification. Classification, kelaskan. So you need to put into different class. Classify the substances in the table number 1 just now into elements and compound. So can we spend another 1 more minute to do revision? What is element? What is compound? Element is something made of one species. Anything made of one species, anything that got one type of atom, anything that got one type of atom, only one species only, that is called element. Compound, you have many species. You have two or more species. When you have two or more species joining together, they are compound. So let's try. Okay, so the first one, iodine. So can you tell me is element or compound? Element type E, compound type C. Element or compound? All right. So element, all right. So Shinin, okay. So Shinin, why is not a compound? Because although you have iodine, I2, I and I, although you have two iodine joined together, but they are same species, right? This is iodine, this is also iodine. They are same type, they are same species. So when you have same species, let's say you have 11 sulfur. So although you have 11 substances, but all the 11 substances, they are same thing, they are sulfur. So they are still element. Okay, are you okay with it, Chini? Okay, so this is element, very good. So copper sulfate, element or compound? Compound. Why? You have copper, which is one species, sulfur, another species, oxygen, another species. You have three species, compound. So aluminium, only one species, nothing else. The aluminium didn't combine with anything else, so it's element. So the next one, tetrachloromethane. You have carbon, which is one species. You have chlorine, which is another species. So when you have two species or more, so it's compound. Okay, so it's quite easy, isn't it? That's how you differentiate elements and compound. Yeah, so let's put it into our table here. So when they ask you to classify, you can write the name or you can write the formula up to your personal preference. You like it lah. Some of you want to write the name, some of you want to write the formula of the substances. Up to you. Okay, because they didn't specify, they only say classify. Yeah? So let's do it. So for me, I'm lazy to write the name. I write formula lah. So iodine, one species is element. I put here. So copper sulfate, three species is compound. I put here. So aluminium, one species is element. I put here, comma. So tetrachloromethane, two species compound. So I put here. All right. So it's very easy. So don't expect they will give you a lot of marks. So it's only 2 marks. Okay. You must get both correct, then only get 2 marks. If the 4 answer here, any one answer wrong, you only get 1 mark. Okay. So you must get all the 4 answers correct, then only you can get 4 marks. Okay. So I think that's it. So you see, this is exactly how they can ask the question for elements, compound, particles when you come to your subjective paper. Okay, so we are done. Okay, we are done with this. All right. So how's everything? Is it okay for you? Okay, all right, great. Okay, so guys, now let us move on and learn something new. So now for the next 1 hour plus, I'll teach you something new. All right, and I want you to pay attention because some the things what we're gonna learn today is very technical. What we're gonna learn today is very technical. Okay, very technical. Okay, not as easy as what you learned last lesson. Okay. Okay, so today I'll teach you something called heating curve and also cooling curve. Okay, heating curve and cooling curve. Okay, so that's what we were going to learn today. So this is something new. This is something that you have never learned back in your PT3. So that's why I really need you to pay attention. And if you have anything that not sure, don't be shy. Just ask the question. Just ask whatever thing that you want to. Okay, if you have anything that you're not sure. Okay, let's start. Okay, first and foremost, Okay, what is the function of heating curve and cooling curve? Why we need to learn heating curve and cooling curve? Okay, so heating curve and cooling curve help us to determine those important things like melting point, boiling point, okay, freezing point, condensation point. Yeah, so you want to find all these important temperature. So that is called heating curve and cooling curve. So heating curve and cooling curve help us to find out what is the melting point, boiling point, freezing point, and also condensation point. Okay, so let's start with the first one. Okay, because many people don't know what is melting point. Okay, let's try this. Okay, guys, if the question asks, what is melting point? Let's say in SPM, they ask you, what is melting point? And then they give you 1 mark. So what you can write? Anyone? You want to try this? Try to answer it. Anyone? Try to type in the chat box. Anyone want to try? If the question asks in your SPM, what is melting point? And they give you 1 mark. So what are you going to write? Anyone? Let's try. Okay. All right. So I can see a few answers here. Okay, not bad. But let me tell you what is the common answer given by students and why the student actually lose the marks. Yeah. One of the common mistake. Okay, one of the common mistake made by student is this. Melting point is a point where solid change to liquid. Okay, melting point is a point where solid change to liquid. So this is an answer that will be given by a lot of students. Okay, many students will answer this. What is melting point? Melting point is a point where solid change to liquid. So if you write this answer, 0, no marks. Why? The whole answer actually is okay, but there's one word goes wrong. Okay, in chemistry, if you write the wrong keywords, although only one word is wrong, everything is wrong. Melting point is not a point. Yeah, melting point is not a point like this. It's not a point on a graph like this. No. Melting point is a temperature. For example, what is the melting point for ice? 0 degrees Celsius. What is the melting point for aluminium, for example? 2,700 degrees Celsius. You don't need to memorize that. So all these melting point is what? They are a temperature. Melting point is not a point. Okay, so this word is wrong already. So melting point should be what? So what is the correct answer? Okay. So melting point is a, okay, learn this word now, guys. Constant temperature. Okay. Okay, where solid change to liquid. That's it. Okay. So just change the keyword, then you will get the answer. Okay, what do we mean by constant temperature? Because the melting point didn't change. For example, melting point for ice is 0 degrees Celsius. Okay, all the way. You won't say it all. Today, melting point for ice is 0. Tomorrow, the melting point for ice is 3 degrees Celsius. The day after tomorrow, the melting point for ice is 10 degrees Celsius. No, melting point of ice is forever 0 degrees Celsius. So the melting point never change. Anything never change, we use this word, constant. So melting point is a constant temperature where solid change to liquid. So if they ask you, okay, what is boiling point? Same thing. What is boiling point? Boiling point is not a point. Boiling point is a constant temperature where liquid change to gas. That's it. All right. So please remember, melting point, boiling point, freezing point, they are not a point. They are temperature. Yeah, they are specific temperature when you change from one state to the other state. So can you please let me know in the chat box? Are you okay with this? Okay. So as simple as that. Yeah, this is a very easy one, but trust me, this question was so easy. But if this question came out, around half of the students won't be able to get full mark. Around half of the students will get 0 mark because they write melting point is a point lah, whatever thing lah. They write a lot of funny thing. Okay, so please remember, all these point, they are not a point. They are temperature. They are temperature. Okay, now, okay. So some of the school will teach you this. Melting point is a constant temperature where solid change to liquid at atmospheric pressure. Is this answer correct? Yes. But do you need to write this red color thing? No need. SPM, no need. When you go for higher level, like from 6, A level, foundation, then yes, you need to write this. But in SPM, you don't need to write this. Okay? You write until here is good enough already. Yeah? So that's it. Okay? So make sure everyone know what is melting point, boiling point, all these things. Okay, now settle. So the next thing I want to teach you is what? How are you going to recognize that you have heating curve or cooling curve? Okay, so I want to show you how the heating curve and cooling curve looks like. Okay, because there are a few things that you need to learn today. Number one, I'll teach you how to identify the shape. When you look at the shape, you will know it's heating curve or cooling curve. Number two, you must be able to analyze. You must be able to analyze, do the analysis for heating and cooling curve. The last one, you must be able to explain using heating curve and cooling curve. So today, the whole lesson, we were just talking about heating curve and cooling curve, and we will do a lot of questions like this. Today, we will do a lot of questions. All these heating curve, cooling curve, heating curve, cooling curve. We'll do a lot of questions. Okay, so that's what we will do for the next 1 hour, 15 minutes like that. Yeah, so let's start. Okay, so first of all, I want you to identify the shape, how the heating curve and cooling curve looks like. So the shape of heating and cooling curve. Okay, the shape of the heating or the cooling curve. So the heating and cooling curve, the shape, they look like a staircase. Okay, staircase. So staircase. So if you learn in BM, staircase means tangga lah. Okay, they look like tangga. Okay, let me show you. Let me show you. Okay, like this. You see? Can you see like tangga? Okay, a staircase, tangga, night. Okay, then you also have the tangga. See, tangga. All right. So this one, tangga. All right. One more. Now this one tangga, but going down. So you have two lah. The ladder go up and the ladder go down. Okay. So when you see a ladder or you see a staircase, then you know it is heating curve or cooling curve. So the only difference very simple lah. Okay. All right. So this is heating curve, how it looks like. Okay. So heating curve is actually the staircase that is going up. Staircase that is going up, or we call ascending staircase going up. So you look at this. So here you have a y-axis, which is temperature. Just when we heat something, the temperature change. Okay. Then the x-axis not important. This x-axis, okay, is time. Okay. You want to see what is the time. Okay. Like you heat for 1 minute, 2 minutes, 3 minutes, whatever. Okay. So heating curve, you will see the staircase going up like this. Staircase going up, then you will see flat and going up like this. Okay, so that is heating curve. Okay, so when you come to like cooling curve, okay, when you come to like cooling curve, so you will see the staircase as well, but now the staircase is going down. It's a descending staircase. It's a descending staircase. Okay, the staircase will go down. Okay, like this. So let me copy and paste. Okay, like this. Okay, your staircase now will go down. All right. Okay, so that's it. So do you need to purposely memorize? No, you don't need to memorize. You just use common sense. When you heat a substance, the temperature will increase or decrease. Increase, right? When you heat a substance, it becomes hotter and hotter. Temperature will go up. So that's why go up. The staircase go up. When you cool down a substance, temperature will go down. That's why the staircase go down. So just use common sense. No need to purposely memorize. No need to purposely memorize. Okay. So when you come to the heating and cooling curve, sometimes you have one staircase, sometimes you have two staircase. Sometimes you have one staircase, sometimes you have two staircases like this. Okay. Okay. Let me like this. Okay. So sometimes you might have two staircases like this. Up, flat, up. This is one staircase. Then up, flat, up, another staircase. So maximum only two staircases. Never get three. I'll tell you why later. Okay. Maximum only two staircase. Staircase number one, staircase number two. How to know you have one staircase or two staircase? Look at the horizontal line, the flat one, the flat one. You have one flat part, one staircase. Two flat part, two staircases. Same thing. Cooling curve also can have maximum two staircases. So cooling curve maximum is two staircases like this. Okay. Cooling, when you cool down something, temperature go down, flat, go down, flat, go down. How to know you have two staircase? Look at the horizontal line, one and two. So two horizontal line means two staircases. One horizontal line, one staircase. That's it. So make sure you know it. No matter heating or cooling curve, okay, maximum only two staircases. All right, so this is a side notes, a tips for you all. Okay, a short tips for you all. So you only have maximum two staircases. Cannot go more than that. Okay, up to this point. Is it okay? All right. So next time when you see this is easy to analyze. So let me show you. Let me show you using a simple example. Okay, so you can see this is a heating or cooling curve. Everyone, heating or cooling, heating type H, cooling type C. Heating or cooling? Heating, because temperature go up, isn't it? Temperature go up, so it's heating curve. So you see, one staircase. Okay, makes sense. Okay, so this is a cooling curve. Temperature go down, one staircase. Okay, this okay. Anything here? Let me see. I think there's one more. Let me double check. Just a moment, please. Okay, this is a heating curve. Temperature go up, two staircases. Yeah. So make sure you know. So from now onward, from today and onward, when you see the staircase, you know already they are heating or cooling curve. Okay. And you can use this heating or cooling curve to find those temperature like melting point, boiling point, freezing point, condensation point. I'll teach you how to find later. So for now, our first objective is that we want to learn how to differentiate. That's why I think the first, we have to do step by step. First thing, I teach you how to identify the shape. So now you know already the shape is staircase. Go up, go down. Maximum two staircases. Okay, next one. Now I'll teach you how to analyze and explain. So I'll start with heating curve. I'll teach you everything you need to know for heating curve. I'll spend quite a long time, 30 minutes like that. Okay, 30 minutes or more. So I want you to pay full attention for heating curve, because if you understand heating curve, cooling curve is not so hard. Okay, but if you don't understand heating curve, there's no way you can do cooling curve at all. Yeah, so please pay attention. So now I'll teach you. I'll start with heating curve. So I'll start with heating curve, and right after this we will do a lot of good quality question so that you know exactly how the question can be tested, how to apply all the knowledge that you learned so far. Okay, heating curve. So first of all, heating curve, okay, like what I said, is the staircase going up. Okay. So first of all, you must know how to the experiment setup. This is the experiment they do, okay, to do the heating curve. So heating curve is do like this. Experiment apparatus for heating curve. So when they want to do heating curve, this is the experiment. Do you need to memorize the experiment? The answer, no need. Right, look at this. So first of all, you have a beaker. This beaker inside got some water, okay? And then here you have a boiling tube, okay? We call it a boiling tube, all right? So in the boiling tube here, you put your substance. Okay, let's say here we have some substance. So this substance, let's say this substance is a solid, okay? You call it a solid. So this substance is a solid. I call it X, okay? Can be W, X, Y, Z, whatever, A, B, C, D, E, any unknown also can, solid X. I just call it X. Then here I need to put a thermometer. Why we need to put a thermometer? Because remember, heating and cooling curve, we want to check the temperature. Heating and cooling curve, the most important thing is we want to study the temperature. So you must have a thermometer. So the thermometer must touching the solid. If you don't touch, you don't know the temperature of the solid. Okay, so this is your thermometer. So do you need to know how to draw this diagram? It's good to know. Would they ask you the question? Maybe, but the chances is not so high. They didn't ask so frequently on how to draw a diagram, but it's always a good idea if you know how to draw it. Okay, so then at the bottom here, you need to heat it. You need to heat the substance. Okay, you need to heat the substance. So here, okay, we heat the substance. So in chemistry, this is how we draw. Sometimes they don't use the arrow and the heat. Sometimes in chemistry, the heat can be represented by this. If you see a small triangle at the bottom, this triangle means heat. When you see triangle means heat in chemistry, okay? So that's it. So I heat the substance. So this is called heating curve. Okay, so now listen carefully. So the first thing, this kind of heating is called indirect heating. This kind of heating is called indirect heating. Why? We heat the water first, then only the hot water will heat the substance here. Because we have two types. One is this. If let's say you take the test tube, directly put under fire, okay? This is called direct heating, okay? Then now in this case, we go to heat the water, then only the water eventually heat the substance. So this is called indirect heating, okay? So here, one of the first question they love to ask in SPM is this. This water is used to heat the substance. So this water has a name. We call it water bath. Okay? We call it water bath, all right? It's like this thing immersed and taking the bath inside the substance. This is called water bath. Sometimes they don't use water. Sometimes they change the oil bath. Same thing like oil bath means what? You heat the oil. When the oil is hot, the hot oil will heat the substance for us. Okay. Sometimes they use a sand bath. So they put some sand here. You heat the sand. When the sand is hot, the sand will go to heat your substance. Okay. So three possibility. Water bath, oil bath, or sand bath. Okay, you have three possibilities. So now, the first popular question in SPM they love to ask is what? What is the function of water bath? Why we want to use water bath? To heat our substance. Why? Why don't you just heat the whole thing directly under fire? Why don't we do direct heating? Why? Why we have to use the water bath to do indirect heating? Why need to be so troublesome? Why need to be so troublesome? Why need to be so many patterns? For simple reason, listen carefully. Water bath can ensure that we have let me write nicely. Okay. Water bath can ensure that we have a uniform. You can say uniform or you can use the word even. Okay, heating. So the heating can be very, very nice. Okay, what do you mean by the heating very, very nice? Okay, look at the picture here. If you put this whole thing directly under fire, let's say, this is the fire. Okay. So if you put the whole thing under fire, maybe the fire is the fire will heat up this part. You see, the fire is here, right? Turn out the fire is here. So this part will become more hot compared to other part. Not good. We want every part to be equally heated. We want every part to be heat equally. You don't want to heat here only. So if you put thermometer, this part is very hot. If you put thermometer here, this part not very hot. So this is not good. But if you do indirect heating by using a water bath like this, no problem. Because when you heat the water, now the water is hot. The hot water will heat in all directions. The hot water will heat the substance in all directions. So every place of the solid is heated. So every part of the solid is heated, which is good. So if you put thermometer, if you check the temperature here, same. Temperature here, same. Temperature here, same. Temperature here, same. Okay, so that's it. So this is called uniform heating. You can say, what is the function for water bath? To ensure uniform heating, or you can say to ensure even heating. That's it. All right. So up to this point, do you guys understand why we do indirect heating and why don't we do direct heating? Do you understand that? Makes sense to you, right? Okay. So everything you learn must make sense. I don't want you to memorize so many things without understanding. No point lah. You keep on memorize the whole thing, but you don't understand the logic. No point. Okay. So everything you learn must make sense to you. So now you guys know already why we use the water bath to do the heating. Okay. Now listen carefully. Okay. Sometimes they might ask you another question. Sometimes they might ask you another question. So this is a tips. Okay. When we need to replace the water bath to become something called oil bath or sand bath. Because like what I say, you can do indirect heating using water, oil, or sand. So when we need to change the water here to become oil or sand, okay? So you need to do it when we want to heat a substance, when we want to heat a substance, okay, beyond or higher than 100 degrees Celsius. So let's say I want to heat this substance to 300 degrees Celsius. I cannot use water bath because if I use water bath, I heat until 100, all the water will become gas. So all the water will dry. Later the water dry already. You don't want the water to dry, right? Okay. So if you change the water to oil, okay, oil can tahan higher temperature compared to water. So when you heat to 300 degrees Celsius, the oil not boil yet. So when the oil not boil, the oil will not become gas and run away. Also, same thing, sand. Sand also can tahan very high temperature. So when you want to heat to high temperature, you use oil bath or sand bath. Okay, that's it. So this question they asked before in SPM, so it's good for you to know it. Okay. So if let's say I only want to heat this substance to 72 degrees Celsius, do I need to use water bath? Yes or no? Yes or no? If I want to heat this substance to 72 degrees Celsius, do I need to use water bath? Yes or no? Okay, just use water bath, correct? Okay. So if you heat the substance to a temperature below 100 degrees Celsius, then you can use water bath. Only when you heat the substance to temperature higher than 100, then only you use oil bath or sand bath. Okay, simple as that. So now we know already. So this is the experiment for the heating. Okay, so now the next thing. Okay, So now heating curve, how the heating curve will look like? Heating curve, why the heating curve will always look at this one? Okay, so let me teach you the second part already. The second part I want to teach you today is how to analyze, how to do analysis of your heating curve. Okay, so don't worry anything about cooling curve yet. Focus on heating curve first, because if you understand heating curve, cooling curve is very, very easy for you. That's what I'm trying to tell you. Okay, so let's do it. So now, okay, why you get a temperature like this? Okay, so first of all, sometimes they might ask you to sketch a heating curve. Sometimes they might ask you to sketch a heating curve. Okay, what is the difference between sketch and also plot? Okay, sometimes you heard the word plot the curve or plot a graph. Sometimes you heard the word sketch. What is the difference between plot and sketch? Plot need to be very, very accurate. You must use a graph paper. You must put all the points correctly and so on. But when you come to sketch, you not even need to use a graph paper. You just agak only. Okay, agak only like this. Okay, I not even need to use ruler. I not even need to use a graph paper. No need. So sketch, no need to be so accurate. Okay, so one of the common mistake for many people when you come to heating curve is this. You see, heating curve, how to sketch? First of all, the y-axis must be temperature. Okay, the y-axis must be temperature. The unit for temperature is degree Celsius. Okay, so you can write, you can put a bracket, you put degree Celsius inside, or you can slash degree Celsius. So you must put the unit. Okay, then the x-axis here is time. So what is the unit for time? Okay, sometimes in minute, sometimes in second. The question will tell you. Okay, if the question never mentioned, then it's in second. But if the question mentioned, then you follow. For example, you see, now this one, the time is in second. This one, the time is in minute. Okay, this one, the time is in minute. This one, the time is in second. Okay, but the time will never ever be in hour. Okay, so the time can be in second or can be in minute. Depends on the question. The question will tell you, no worry. Some people say, sir, how I know when should I use second, when should I use minute? Not to worry, the question will tell you. Okay, so now, when you sketch the heating curve, many people heating curve start from here. They say, oh, Mr. Martin said heating curve is a staircase going up like this. Okay, so this is wrong. Why? Heating curve, the temperature cannot start from here. This is temperature 0. No, when you first heat a substance, you start from what? Let's say today you have a cup, inside got a substance. When you heat the substance, what is the starting temperature you heat? Okay, anyone make a wild guess? When you heat a substance, what is the starting temperature we heat? Okay, very good, Joseph. Very good, Joseph. 25. Okay, 25. When you heat whatever substance, it always start from room temperature. Okay, always start from room temperature. Okay, unless you're taking something like from the fridge. Okay, from the petit sergio, are they different? Other than that, when you want to heat a substance, the first temperature is always start from 25. So you cannot start from here, because if you start from here, it's 0. So that's why many students make a mistake here. Heating curve cannot start from 0. Heating curve must start from 25. So here is 25 lah. Agak-agak lah, 25. You start from here. Okay? So start from here lah. So then you heat the substance, temperature go up. Okay, when you heat the substance, temperature go up. Okay, then you will see the temperature will become constant. The temperature will stop changing. Why? Okay, when you heat the solid, then when you heat to a certain temperature, the solid will start to melt. The solid will start to melt. So I want you all to know this, okay? When during the change in the state, okay, what do we mean by change in the state? When you change from solid to liquid, liquid to gas, gas to solid, gas to liquid, whatever. When you change the state, always remember two things. Number one, the mass doesn't change. Okay, the mass didn't change. 1 kilogram of water will become 1 kilogram of ice, will become 1 kilogram of steam. The mass cannot change. Number two, the temperature didn't change. Okay, the temperature doesn't change. Like for example, if you want to boil the water, you heat the water in the kettle until 100, then the temperature will stop. Temperature will not go up. You won't get 101, 102, 103. No, temperature will stop at 100 until all the water here boil and become gas. Only when all the water here become gas already, then only the temperature from 100 can go up again, maybe 110, 120, okay? So when you change from one state to the other state, temperature never change one. Like when you melt a substance, the temperature will stop there, never change. When you boil a substance, the temperature will stop there, they never change. When you do a freezing, the temperature will stop there, they never change. Okay, so that's why when temperature never change, so you see a horizontal line. So that's why when you see heating curve, when you see horizontal line here, you know already this is where you change the state. All these horizontal line is where you change the state. This is where melting, boiling, freezing, condensation. It always happens on the horizontal line. So melting, boiling, all these things never happen at here. Never happen at here. Always happen on the horizontal line. Everyone, can you please type in the chat box and let me know, are you okay with this concept of horizontal line? This is very, very important, because now I'm teaching you many puzzles. Later, when we put all the puzzles together, it will become very complicated. That's why I want to make sure you're okay with all these small pieces of puzzle first. All these small concepts you must understand. Then only I connect everything with you. Yeah. So that's it. So settle. Okay. So this is where you start to melt. Okay. This is a point. This is the point when you first start the melting. This is start melting already. Okay. Then all the way until here. So until here, the melting finish. Okay. So finish melting already. So after you finish melting, all the solid here already become liquid. So when they become liquid already, you continue to heat, the liquid temperature will continue to shoot up again. The temperature will continue to go up again until you reach the boiling point, until you reach boiling point. So when you reach boiling point, let's say the boiling point, let's say is 140. Let's say just assume only. All right. So some people say, sir, I thought boiling point is 100. No, not everything the boiling point is 100. Boiling point 100 is only for water. You don't think everything the boiling point always 100. No. So let's say this substance, the boiling point is 140. So when you reach 140 degrees Celsius, the temperature will stop changing again. Why? Boiling will start to take place. So you will start to see bubble, then more bubble, more and more bubble. So the liquid now will become gas. So when boiling is taking place, the temperature now will stop changing again. Because remember, when you change the state, when you change from one state to the other, the temperature always constant. So at this point, this is where the boiling started. So at here, you start the boiling process. So at the end of the horizontal line, this one is where the boiling has completed. You finish boiling. So after you finish boiling, so all the liquid here already become gases. So when you become gas and you heat the gas temperature will go up again. So it will go up. Sorry. It will go up again like this. So let me adjust a bit. Sorry. Adjust here. Yeah. Okay. Go up again. All right. So that's it. Okay. So guys. So now Let me know in the chat box, are you okay with how I produce this heating curve? Are you okay with it? Can you see how the heating curve can be produced now? Okay, so not very, very hard, isn't it? Not very, very hard. Okay, so that's it. So this horizontal line, what happened? Okay, remember when you hit the substance, all these horizontal line is where they change the state. When you hit the substance, what happened first? Melting. So on this horizontal line, melting process take place. On this horizontal line, what take place? Boiling. Okay, so that's it. Okay, so now when you see the heating curve, you know already, okay, like this. Okay, let's say, now this is a heating curve. You should know already the first horizontal line and the second horizontal line. So this is where they change the state. Okay, so what happened first? When you heat the substance, always melting take place, then only boiling. Okay, so the melting and boiling happens on the horizontal line. They happen on the straight line here, on this flat line, not here, not here. Melting, boiling, all these things only happen on the horizontal line. Okay, so where the melting start? Here. Where the melting end? Here. Okay, where the boiling start? Here. Where the boiling end? Here. So you need to know all these things. It's not hard, but it is very, very important. Okay, that's why I go very, very slow to really make sure that you can get the idea. Okay, it's okay to go slow to make sure you really, really can get the idea. Okay, so with that being said, we're done. Yeah, we're done with this sketching of heating curve or cooling curve. Okay, so now we will go on a little bit more. Okay, I'll teach you how to do the analysis. Okay, how to do the analysis. Okay, so now what is the melting point? So melting point is the temperature where melting happens. So this is melting. Temperature is on the y-axis. So you come here, you read this temperature. Let's say the temperature is 70 degrees Celsius. So the melting point is 70 degrees Celsius. So what is the boiling point? This is where the boiling happens. So you go here, read the y-axis. What is the temperature that boiling take place? Let's say 140. So that is the boiling point. Okay, simple as that. Okay, so now let's mix the whole thing a little bit harder. So let's mix the whole thing a little bit harder because one, if you have two staircases, you know exactly the first staircase is melting, the second staircase is boiling. If you have two staircases, but what if you only have one staircase? What if you only have one staircase? Okay, like this. So this one very, very tricky. You have to be super duper careful. Okay, so if you only given one staircase, if you given one staircase, it might be melting or it might be boiling. Okay, if you have two staircase, you know already. Two staircase, the first staircase must be melting, second staircase must be boiling. But if you only given one staircase like this, okay, if you only given one staircase only, maybe it's melting, maybe it's boiling. Okay, I'll teach you how to see later. If you only given, now this one two staircase, very easy lah. Two staircase must two horizontal line. This one must be melt, this one must be boil. Okay, so two staircase easy lah. This one must be melt, this one must be boil. Okay, but what if you only have one staircase like this? What if you only have one staircase like this? So when you only have one staircase, maybe it's melting or maybe it's boiling. So how to know it is melting or it is boiling? So what to do? So you must read the question carefully, okay, to check the starting state. The starting state they give you is solid or they give you is liquid. So if you only have one staircase, you need to check the question because they will tell you that they will give you a solid or a liquid. What does it mean? You see, all right. So let me show you using here. Let me show you using here. All right. Now, guys, this is a heating curve of ice. You only see one staircase. So one staircase may be melting or boiling. So now, how you know it's melting or boiling? So you see what they tell you. This is the heating curve of ice. So ice means what? Solid. So when you start with a solid, common sense, when you heat a solid, what will happen? Melting first, right or not? When you start with a solid, melting will take place. You cannot heat a solid and you will boil. No, you will always melt first. Okay, let's say another one. Let's say here. Now, is there anything here? Just a moment. Okay, here. Ice, solid. Okay. All right. Okay. Okay, here. Let me give you a random one. Let's say I give you a random one. Okay, let's say I give you a heating curve like this, and I tell you this is heating curve for a liquid Z. So now you should know already. So you started with a liquid. If I give you a liquid and you heat it, so when you heat a liquid, what will happen? Boiling. You got it? So what I'm trying to tell you? If you have two staircases, easy. First one melting, second one boiling. But if you only have one staircase, maybe it's melting, maybe it's boiling. So you need to check whether you start from solid or you start from liquid. If you start from solid, then it's melting. If you start from liquid, then it's boiling. Okay? So can you please let me know in the chat box, are you okay with this concept? So it's not very hard, isn't it? It's not very hard, but you have to be very, very careful, okay? It's not very hard, but you have to be very, very careful, okay? So now, okay? So now the next thing, okay, I will go on more detail about this analysis again. We're still in analysis. So let me finish the last part for analysis. Then I'll teach you how to explain. Right? Let me finish the last part of analysis. Then I'll teach you how to explain. Okay. And then we will do a lot of past year question, a lot of state paper to strengthen your concept, to strengthen your understanding. So now, listen carefully. Okay, listen carefully. So let's start. Okay. So let me copy this thing first. Okay. All right. Yeah. So let me do analysis. Okay. So here I have a few regions. Okay. Let's say I do some region here. And then this is the state of matter. Okay. I'll show the region and the state of matter. Okay. Okay. So the first region is here. This region, I call it A, B. Yeah. So A to B, this region. Okay. Then the second region is this horizontal line, B to C. B to C. So B to C, it's here. Then this region from here to here, C to D. And this region, D to E. Last one, this region, E to F. Yeah. So there are total 5 regions here. Okay. C to D, D to E, E to F. Okay. So now I want you to know the state of matter. Okay. So A to B. So A to B is what? You see, melting start here. Here, not melt yet. So if something you not melted yet, so solid. Okay. Something not melted yet, solid. Now this is tricky. B to C, what is it? B to C, melting is taking place. Melting is ongoing. The melting process is ongoing. So at here, melting not finished yet. At here, melting not finished here. At here, melting not finished yet. Melting only finished at here. So along the line, along this entire line, okay, at here, at here, at here, at here, at here, at here, or even at here, the melting is ongoing. So when melting is ongoing, you have solid and liquid. You have both. Because you still have some solid that not melted yet, and some of the solid maybe already melted, become liquid. So you have two. So always remember, when you are on the horizontal line, and when you are on the horizontal line, the change of the state is ongoing. When the change of state is ongoing, you always have a mixture of state. You have solid plus liquid, liquid plus gas, something like that. Okay. So horizontal line always have mix. Okay. So this is very important. Okay. So at here, at this point, the melting already finished. So at here, everything already become liquid. So at this part, do you boil? No, boiling happened at here. So at this part, already melted, but not yet boiled. So at this part, everything in liquid form. At this part, C to D, everything is in liquid form. Then when you come to D to E, boiling is ongoing. So when boiling ongoing, some of the liquid boil, some of the liquid not yet boil. So you should have a mix. Okay, you should have a mixture. Okay, you should have a mixture. Okay, so let me see. Okay. Okay, so at this one, D to E, you should have a liquid mixing along with gases. Okay. Lastly, let's finish it. Then you know it. E to F. Here, the boiling already finished, because at this part, the boiling already finished. So on here, so boiling completed. When boiling completed, everything already become gas. Okay, so it's very easy. When you are on this part, when you're on when you're on all these slanted line, all these line like this, so you always have only one state. Okay, like solid only, liquid only, like that. But when you are on the horizontal line, okay, you always have two states mixed together. Because why? The change of state is ongoing. Melting is ongoing. Ongoing means what? Not finished yet. Okay, boiling is ongoing. Okay, everyone, please let me know in the chat box. Are you okay with this concept? Okay, can I? It's not very hard, but you all have to be very, very careful, okay? So that's the reason why I go super, super slow, because I really want to make sure you all really can get the idea here, okay? Some of the school can finish this entire heating curve in 20 minutes. Some of the school can finish the entire heating curve in 20 minutes. For me, I spent about 1 hour just to teach you heating curve, because I want to make sure you really can understand. Because if you really understand heating curve, cooling curve going to be very easy for you, okay? So that's it. Okay, so now, before we move on to the last part, which is the explanation, now I would like to give you a quick self-test. Okay, can I give you a self-test that everyone can try to do together? And I hope everyone try to participate in this. Okay, type the answer in the chat box. Okay, like this. Okay, so this is a temperature, and then this one is the time in minute. All right, and then you are given a substance like this. Okay, all right. So the diagram above show the heating curve of, all right, let's say teh tarik. Okay, so this is the heating curve of teh tarik lah, just an example lah. Okay, so let's say, so this is called T1, time number 1. This is time number 2, which is here. This is time number 3. And this is time number 4. Okay. All right. So now this question a little bit special. Okay. I want you to state the state. All right. At T1, T2, T3, and T4. So now I'm not going for a region. I go for one particular point. Okay. So let's try it. Okay. Let's try. Okay. Let's say if you think T1 is liquid, you type like this. Okay. You type L. T2, if you think it's a solid, you type S. If you think it's a gas, you type G. Okay. So let's try. Okay, everyone, can you type in T1? You think T1 is solid, liquid, or gas? T1. Okay, very good. Good answer. It's a liquid because you're starting. So when you have one staircase, maybe it's melting, maybe it's boiling. So you have to check what they give you. Teh tarik. So teh tarik is liquid. So they give you a liquid. So when you have a liquid and you start to heat it at T1, melting not happen yet. So when boiling not happen yet. So when boiling not happen yet, everything is in liquid form. Fantastic. Okay, what about T2? At T2, what is the state? Anyone? What is the state at T2? At T2 here, what is the state? At T2, what is the state? Okay, all right, let me check the answer here. Okay, okay, so okay, Joseph, Ejim, Alia. Okay, very good. Okay, so it's liquid and gas. Why? Because at here, melting, boiling start. You start boiling at here. So when you first start boiling, so if you have a liquid, when boiling started, just started, so you still have liquid, but you also have some gas. Okay. All right. So at this point, the boiling, so it's ongoing. So you have liquid and gas. Okay, let's say I add another one more point. Let's say here I add T3, T4, and T5. Okay, so what about T3? So T3, it's here in the middle. So T3 in the middle, boiling is ongoing. So here, boiling started. So when boiling start, already have gas and liquid. Okay, when boiling start, already have gas and liquid. So in the middle here, boiling ongoing. So when boiling ongoing, still got liquid and also have gas. Okay, so liquid and gas. Okay, so liquid and gas. Okay, so what about here at T4? What is it? T4. Okay, very good, Cecilia. Very good, Liling. Okay, so at T4, it's gas because at this point, boiling ends. Here, boiling started. Here, boiling end. So it's always like this, a line, start and end. So at here, the boiling already finished. When boiling already finished, everything should become gases already. So everything already gas. So lastly, at T5, which is here. So for sure it's gas lah, because here already gas what? So here everything already become gas. So if you continue heat, so it is still gas. Okay, because gas cannot become something else. Okay, finish. Okay, so this is a very simple self-test question to really check on your understanding. Do you understand what we have learned so far? Yeah, this is a very good question to test. Do you understand what we have learned so far for today? Yeah, so that's it. Okay, so now we already understand the concept of the heating curve and also the states here. All right. So let me know up to this point, is everything okay for you? Okay, guys can follow up. Okay, very good. So now I'll go on to teach you the last part for heating curve. Then we will do state papers. Okay, I'll teach you the last part for the heating curve. Then we will start to do some state paper together. So you will know how to apply the knowledge. Okay, so now same thing. I'll use back this thing. Okay, and then I will give you some explanation. I'll give you some explanation. Okay. Now, this explanation will be very, very important. Okay, and it can be quite tricky for some of you. Okay, for some people, it might be very tricky. That's why, if anything you're not sure when I do the explanation, please, okay, ask me. Please ask me. Okay, very, very important. Okay. Okay, so now I will explain what is happening at here, at here, at here, at here, and at here. Okay, so this explanation, like what I say, can be a bit confusing. So listen carefully. Listen carefully. All right. Right. Then after that, we do past year question. We do state paper. You will understand even better. Okay. So let's start. Okay. So let me give the excuse me explanation. Okay. So I need to explain what is happening at each region. Okay, so we have many area, many region. So I need to explain to you what is happening. So let's start with this. Okay, A to B. So from A to B, this is very, very easy. So what happened? Okay, just imagine A to B, everything still in solid form. So just imagine this. Okay, so A to B is a solid. Do you have melting process? No. So just imagine, let's say you have some solid like this. This is solid. So they are squeezed together. Okay. So now you heat the solid. Okay, you heat the solid. So does the melting happen here? No, melting not happen from in AB. Melting only happen in BC. So what happened here? Just imagine all the solid particles, they have energy, right? All solid got energy. Okay, for example, this solid got energy 10 joule. Joule is the unit of energy. J is joule. Joule is the unit for energy. You'll learn more in physics. So let's say this solid have 12 joule. Not to say all the energy is the same one. The energy can be a bit different one. Okay. So let's say this solid, the energy is 11. This one, the energy is 12. This one, energy is 11. This is 13. This is 10. This is 10. This is 13. Are these number important? No. All these number not important. No need to memorize. Some people focus on the wrong thing. So I need to memorize the 10, 11, 12. No need. So I just want you to know, these are all solid. All the solid got energy. Just like this, okay? So just imagine like this. This is a human. This is a human. This is a human. Solid sticking together. So they're holding their hand. So every human got energy. Let's say this is me. I got 10 joule. This is you. You have 12 joule. This is another person, 11 joule. So we are solid. We hold our hand sticking together and we have energy. Okay. So this energy called kinetic energy. In chemistry, all the energy that we have is called kinetic energy. So when we heat the substance, when you heat a substance, the energy will go in. That's why, for example, you have a piece of metal. When you heat the metal become hot. Why the metal become hot? The energy go inside the metal. The energy go inside the metal. So let's say when we heat, the energy go inside here, the energy go inside here, energy go inside, go inside, go inside, go inside, go inside, go inside, go inside. Okay. So when energy go inside, what do you expect? All the particle here should have more energy. Okay, because when you heat the substance, the energy go inside, so they should have more energy. So now the energy change. Okay, let me write quickly. Okay, so this one you will see something like this. So initially the energy is 10, now maybe become 13, 12 maybe become 16 and so on. Okay. So I just want you to know that now all of them got more and more energy. Yeah, that's it. So when all the solid got more energy, what you can see. Okay. So kinetic energy and also temperature, these two things, they are adik beradik. They are brothers. Yeah, they are brothers. They are good friends. Whatever things happen to kinetic energy, the same things will happen to temperature. Like kinetic energy increase, temperature energy will increase. Kinetic energy decrease, the temperature must decrease. Kinetic energy no change, temperature no change. So kinetic and temperature is adik beradik. Whatever things happen to kinetic energy, same thing with temperature. So when you heat the substance, all the solid got more and more energy, right? Why? They absorb the heat, right? All the heat go into the solid. We call it absorb the heat. So when they absorb the heat, all the solid got more and more energy. What is the energy? Kinetic energy. When kinetic energy is higher, temperature also higher. That's why from A to B, can you see the temperature actually become higher? The temperature go up, isn't it? Temperature go up. Okay. So how to explain? How to explain? From A to B, all the heat is absorbed. Okay, all the heat absorbed. Okay, by who? All the heat absorbed by this solid particle. Okay, all the heat absorbed by solid particles. Okay, all the heat absorbed by solid particles. So when they absorb the heat, what happens? So they have more and more energy, right? Kinetic energy increases. So but in exam, you cannot write the arrow. In exam, you cannot write the arrow like this. In exam, you must write increases. I'm lazy. That's why I put the arrow here. In exam, you are not allowed to put the arrow. Okay, I just put some shortcut. So when kinetic energy increase, the brother temperature will also increase. So this is what happened at here. So everyone, can you please let me know in the chat box? Are you okay with this? Okay, can I? All right, good. So now, so B to C is where everything become complicated. B to C is where the whole thing become complicated. And this is where they love to ask the question. I put 5 star because it's so important. They always love to ask here, the horizontal line. In exam, they always love to ask this horizontal line. They seldom ask this one, here, here, here. The line go up, they seldom ask one. They always ask the horizontal line, okay? So now, what happened here? From B to C, okay? Now, melting is happening, right? Melting is taking place, So, melting take place. So when melting take place or melting occur, so what happened? Now, this is very tricky. Listen carefully. Do we still absorb the heat? Yes. In heating curve, no matter you are here, 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 or here, you always absorb heat. I repeat, in heating curve, no matter where you are, here, 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 you always absorb the heat. But now, why the temperature now stop changing? Why the temperature never change already? Now, this is tricky. By right, when you absorb the heat, you got more and more energy. By right, temperature should go up, right? But how come the temperature no change? Why? Why temperature no change? So listen carefully. Okay, so let's look at the particle here. So now, when you heat the particle, by right, the heat should go in, How come the temperature not changing? Because, listen carefully, Now, melting is taking place. So when melting is taking place, what you want to do? You want to change the solid here to become liquid. So when you want to change solid to become liquid like this, you need to break the bond, right? You need to cut them away because initially they're sticking together, right? There are many glue. They glue together. So if you want to become liquid, you want to cut. You need to take a knife and cut them away, just like this. So solid, they hold their hand together. So if you want to become liquid, you need to take a knife and separate them. You need to separate them away, okay? So that is what you need to do during the melting process. During melting, you want to break them apart, okay? So now you have to know, okay, this, when they hold their hand, this thing is called force of attraction. They have force of attraction. So you want to break the force of attraction. We don't use the word break. We always use the word overcome. We use the word overcome force of attraction. So overcome force of attraction means you're breaking the glue. They glue together, right? So how you want to break the force? You must use a knife. So this knife is the heat. So now you will use the heat, okay, this heat, you will use this heat to break here. You use the heat to break here. You use the heat to break here. So all the heat you use to break them apart. So when you use the heat to break them, does the heat go into the particle? No, the heat didn't go in. The heat didn't go into the particle. All the heat, you use it to break them apart. You use the heat already. So when you use the heat, no more heat can go into the particle. So when no more heat can go into the particle, all the energy here didn't change. So let me know in the chat box, can you imagine what is happening or not? Okay, so that, okay, anyone cannot imagine? Is there anyone cannot imagine what is happening? Anyone? Let me know in the chat box if you cannot imagine. This is very, very important. That's why I don't want you to memorize a long words like this. I want you to imagine. Okay, I want you to imagine. Okay, how are we going to put in words? So when melting takes place, what happened? So this is very important. So let's use the red color. All the heat absorbed. So all the heat that we take in, they become the knife. Okay, is used to overcome the force of attraction. All the heat that we absorb, we use them to overcome force of attraction. Force of attraction for what? Force of attraction between solid particle, because who is sticking together just now? Solid, right? All the solid is sticking together. So we use the heat to be the knife to cut them apart. So we cut the solid. So we don't use the word cut lah. We use the word overcome force of attraction. Okay, so that's it. So when all the heat you absorb is used here, so all the particle here, their kinetic energy, no change. So kinetic energy remain unchanged. Okay, because no heat go inside the particle. No heat go inside the particle. The heat come to here to break the bond. So when kinetic energy no change, temperature also no change. That's it. So that's why the temperature never change during the melting and boiling process. Okay, this is a very, very popular question, which they give you 2 marks normally. Okay, which I will show you. Okay, I'll show you. I'll demonstrate. Okay, so let me know in the chat box, how's everything so far? Can I? Okay, so now let us spend 10 minutes, around 10 minutes, 10 to 15 minutes to do some good quality question. So we have learned, we have finished already. Okay, we have finished already. Okay, some student ask what happened to C to D, D to E? It's the same thing. C to D, exactly the same. C to D, you copy the A to B here. You copy the A to B here, okay, to make it become C to D. Okay, why? Why you can copy? Because from the C to D, what happened here? C to D, everything is in liquid form. You didn't have boiling process, not boil yet. So the liquid not boil yet. So when the liquid not boil, all the liquid, you heat it. The heat no need to break the bond, right? The heat no need to break the bond. All the heat, you don't need to break the bond. All the heat go into the particle. So all the liquid got more and more energy. When liquid got more and more energy, the liquid become higher temperature. So you just copy the A to B, just change the word solid here become liquid. Yeah, just change the solid here become liquid. That's all. because now everything is in liquid form. Yeah. So the liquid, you absorb the heat. When all the heat go into the liquid got more and more energy. When liquid got more energy, liquid got higher temperature. Simple as that. Okay. So why the heat can go into the liquid? Because now this part no boiling yet. So no boiling, no need to break the bond. So no need to break the bond, the heat can go inside the particle. If you want to break the bond, the heat need to come here. The heat cannot go inside the particle. So that's why you have to know where the heat will go. Okay? Same thing. Okay, what if they ask you D to E? D to E, same thing lah. D to E is the horizontal line. So same as here lah, horizontal line. So just copy paste the answer. Yeah, just copy paste the answer here. Just modify a little bit. Okay, just copy paste the answer here and just do some modification. Okay, let's modify it. Okay, so here, all right. So here we have D to E. So D to E, what is the process that takes place? So D to E is here. So this is boiling. So just change the word here, become boiling. Okay, change the word here, become boiling first. Okay, boiling take place. So during boiling, what happened? During boiling, all the heat, where they go? Yeah, boiling. Boiling want to change the liquid to become gas. So when liquid want to become gas, you need to break the bond. So when you want to break the bond, you need to use the heat to be the knife. So now the heat come to cut the bond, come to cut them. So the heat didn't go into the particle. So when the heat didn't go inside the particle, this particle energy no change. When particle energy no change, temperature no change. So you see, just copy the answer, change a little bit. All the heat absorbed is used to cut the bond. Don't use the word cut, overcome the force of attraction. But what is the force you want to overcome? Between liquid. Because why? Boiling want to cut the liquid to become gas, right? Just now melting cut the solid to become liquid. Okay, so please make sure you know it. So this one only change the word here, become liquid. Okay, other than that, everything's still the same. All right, finish. Okay, so that's all. Okay, so let me know in the chat box. Is it okay for you? Okay, can right, good. So now I won't teach you anything new already for today. So now for the next 10 to 15 minutes, let us do some past year question. Let us do some state paper so that you can see how the question can be tested, how they ask you the question in the real examination. So let's start. Okay, here. All right. Okay. So I start from some objective first, then only I go to subjective. Okay, so let's start with this. So this is what? Heating curve, staircase going up. So you know the first flat one is melting, second one is boiling. So they ask, which of the following show the strongest force of attraction between naphthalene particle? Okay, what is the force that you need to know? So force is what? Solid glue together. So when they stick together, the force is very strong. Liquid, some glue together, some they don't. So the force is moderate. Gas, they only glue a bit. Yeah, so the force is very weak. So when they say strongest force between particle, actually they are talking about solid. So the question asks, where is solid? So where is solid? Okay, so here, isn't it? This is melting. Before melting, everything is solid. PQ. Do you understand how I get this answer? Anyone don't understand what am I doing? Anyone? Let me know in the chat box. Anyone don't understand what am I doing, or I'm doing too fast, too expert? Let me know. Okay, I hope everyone can understand. So let me know in the chat box, is everyone understand how to do this question? Everyone, I want to see the response from you guys. Okay, very good. Okay, thanks for responding. Okay, next one. This is a Kedah. This is a Kedah paper objective. So this is also a heating curve. How many staircase we have? 1 and 2. So remember how to see the staircase. Look at the horizontal line. 2 horizontal line. So 2 staircases. So 2 staircases, very easy. The first one must be melting. The second one must be boiling. So now which of the statement is correct? This is good. Q exists as liquid at 258 degrees Celsius. Okay, so Q exists as liquid at 258. So let's look at here. 258 is here. So are you a liquid at 258? No, because at 258, boil. So at here, boiling take place. So when boiling take place, is either you have gas, so not yet gas, because at here, the boiling still ongoing, right? Horizontal line, boiling ongoing. So when boiling ongoing, so you should have solid, so you should have gas and liquid mixed together. So no, should be gas plus liquid. So not only liquid, wrong. B, Q exists as solid at T1. So let's look at T1. So T1, what is it? So this is melting. Here is before melting. So before melting, this is solid. Okay, before melting, this is solid. At here, T1, melting started. So when melting start already, you have solid and some liquid already. So wrong. Okay. So answer C. Q exists as liquid at T2. So let's look at T2. T2 is here. This point melting, finish. So when melting already end, when everything melted at here, liquid. So it is liquid. So do you guys understand how I solved the question, everyone? Can, okay? So that's exactly how it works. So not very hard. I didn't say it's easy, but it's not hard at all. It's not hard at all if you understand the concept. So let's do one more objective here. Then I show you some subjective question. Let me show you, let me finish this objective. Then we do one or two subjective questions to finish off with today's class. Okay, this is MRSM state paper. So you are given a heating curve. So only one staircase. So one staircase has to be careful. Maybe it's melting, maybe it's boiling. So they tell you this is the heating curve for a solid. So when you have a solid, you heat the solid, melting take place. So this is melting. Okay. So now, how to do it? So which of the statement can be deduced, okay, from the diagram number 8? Deduce means conclude, conclusion. No heat is absorbed in the first 2 minutes. In the first 2 minutes, no heat absorbed. No. Heating curve always absorb heat. No matter you are here, you are here, you are here. Heating curve always absorb heat. So wrong. Acetic acid need 8 minutes to melt. Okay, what is the time to melt? At here, melting started at minute number 2. At here, melting completed, minute number 6. 6 minus 2, 4 minutes. You need 4 minutes here for the melting to take place. So here they say 8 minutes. Wrong. Answer C. Acetic acid undergo physical changes from 2nd minute to the 6th minute. Yes, from the 2nd minute here to the 6th minute here, you have some changes, which is melting. You change from solid to liquid. So that is a physical change. So the answer is C. All right. So why the answer cannot be donkey? The attractive force becomes stronger after 6 minutes. So you see, after 6 minutes, who you are. Before 6 minutes, here everything is solid. After 6 minutes, melted, become liquid. Liquid, the force is weaker, right? Because solid, everything sticking together. Liquid, not everything sticking together. So the more they stick, the stronger the force. So liquid not sticking so much like solid. So liquid, the force should be weaker than the solid. But now the answer say stronger. That's why it's wrong. So guys, can you please let me know in the chat box? Are you okay with this question? Not very hard, isn't it? So that's exactly how we apply the knowledge that we learned today. Okay, so now let me show you some subjective question. So let me show you some subjective question. Okay, all right, here. Okay, just a moment. Subjective question. Okay, here. Okay, this one. Okay, this is a Pahang paper 2022. Okay, so you are given a heating curve. So one staircase may be melting, maybe boiling. So they say you have ice. Ice is a solid. So when you start with a solid and you heat the solid, melting. Okay, so it's melting. All right. So now, what is the particle in ice? So particle means atom, molecule, or ion. So ice is made from water, right? H2O. Water in solid form called ice. Water in liquid form called water. Water in gas form called steam. But all of them are H2O. So H2O, tell me, atom, molecule, or ion? Tell me, atom, molecule, because why? Hydrogen is a non-metal, oxygen is a non-metal. Non-metal sticking together, molecule. Okay, non-metal sticking together, molecule. Molecule or molecules, with or without S is okay. With or without S is okay. Doesn't matter. Doesn't matter. Okay, finish. Okay. So now, next one. What do we mean by melting point? Something I asked you early on today. Melting point is not a point. Yeah. Melting point is a constant temperature. Okay, what's so special about this temperature? At this temperature, solid become liquid. Okay, where solid change to liquid. Okay, solid change to liquid, and that temperature is called melting point. Okay, so remember, it's constant. The temperature doesn't change. Okay, settle. All right. Sometimes even you don't write the word constant, you only write the word temperature where solid change to liquid. Sometimes they give you correct also, but to be secure, to be safe, better you write the word constant temperature. Okay, next one. What is the physical state of ice during the melting process? During the melting, when melting is ongoing, solid and liquid. Mr. Martin, can we change the sequence? Can we write liquid and solid? No problem. The sequence doesn't matter. Okay, you write solid first or you write liquid first, doesn't matter. Okay, doesn't matter. All right. Can you write the word plus, solid plus liquid? Yes. Okay, you can write solid plus liquid. No problem. It's okay. Acceptable. Yeah. Right. So now, next one. The last question for today. Why the temperature remain constant between B to C even when the heating continue? Okay, B to C here. So why during the melting process the temperature didn't change? That's why I say these are the very popular questions. They always ask you what is happening at here. They seldom ask you what happened at here. They seldom ask you what happened at here. They always love to ask you what happened at here. Look at how many marks they give you. This question, they allocate 2 marks for us. So simple rule of thumb, 2 marks, you should write 2 answers. So like what I say, why? Why temperature never change? Okay, because we know the process is melting. During melting, what happened? All the heat come in to be the knife, right? The heat become the knife to cut the bond. Okay, so all heat absorb, all the heat absorb. Okay, sorry, I should add the word the. Okay, all the heat absorb. You use it. You use the heat somewhere. Is used to overcome force of attraction between who? Okay, so when you want to melt a substance, you want to cut the solid, right? This is solid, it's sticking together. You use the heat to become the knife to cut. Okay, so you want to cut the solid. So between solid particles. Okay, so when you use all the heat to cut the bond, when all the heat you use to cut the bond, so no heat can go into the particle. When no heat go inside the particle, this particle energy don't change. So kinetic energy of the the kinetic energy of the particles remain unchanged. So when kinetic energy no change, temperature do not change, because like what I say, kinetic energy and temperature is adik beradik. Okay, kinetic energy don't change, temperature don't change. Okay, so actually if you don't write this line, it's okay. how they give you the 2 marks? They give you the 2 marks when they see the word heat absorb, they give you 1 mark. Overcome force of attraction, another mark. But I will encourage you write everything. Write the answer as complete as possible. I would strongly encourage, the more complete the answer, the better it is. Okay, so with that being said, we are all done with the learning of heating curve. So this is the last question for today. So let me know in the chat box, how's everything? Do you learn something today? Okay, very good. Okay, thanks for the response. Not very hard, isn't it? Okay, not very hard, huh? Okay. So, but what we learned today is not so easy. The one we learned last week, super easy, because it's something that you have seen in PT3. But what we learned today, heating curve, cooling curve, is something totally new. That's why I want to make sure you really understand what you learn, okay, and what is going on. All right. Okay, I think that's all. So today we finished with the heating curve. So by next lesson, I'll teach you cooling curve. And when we learn cooling curve, it's much easier and much faster, because if you understand heating curve, you shouldn't have a big issue with cooling curve. Okay, so I think that's all for today. So I'll see you by next week then.